equations. Equations can be solved and they have a single number that makes the equation true. Make sure that you're recording this in your notes as we go along. You can have printed your notes out and record it, or you can do it in the digital form. Either is fine. The solution is the number that makes an equation true. So what number can we plug in that's going to make it true? It's going to equal. So let's look at these. We want to check if these are solutions to these equations by plugging them in. We've done this. When we evaluated expressions, we've already done this. So let's look at ay plus 2 equals 3. So if y is a half, and we plug it in and do the math, will it equal 3? So 8 times a half, we've put a half in for y. Following order of operations, we do the multiplication first, so that would be 4, and then we would add. So does it equal it? No. So is a half a solution for this equation? No, it is not. Let's look at the next one. 13 equals x divided by 3 minus 5. So if x is 54, will that be a solution? So let's plug in 54 for x. We have 54 divided by 3 minus 5. Order of operations says that I divide first, which would be 18, and then I can subtract the 5, which would be 13. 13 equals 13. Is 54 a solution for this equation? Yes, it is. Let's look at the next one. Z squared minus 8 equals 1. If z equals 3, so is 3 going to be a solution here? We're going to plug it in for z. So 3 to the second power minus 8 equals 1. Order of operations would say that I need to do my exponent first. So 3 times 3 is 9. And then I can subtract. 9 minus 8 is 1. So is 3 a solution for this equation? Yes, it is. So as we move on, we're going to solve equations. We want to isolate the variable, meaning we want to get that variable alone because we want to find out what it's equal to. So by using our inverse operations, that's the opposite operations. So if I see adding, then my opposite or my inverse operation would be subtracting. If I see subtraction in the equation, my inverse operation or the opposite would be to add. That's how do I undo it? If I see multiplication, the inverse operation or the opposite to undo things would be to divide. And last, if I see division, the opposite or inverse operation, what am I going to do to undo is multiply. Think of an equation as a balanced scale. Whatever we do to one side of the equation, we need to do to the other because we want to keep it equal. We want to keep it balanced. That's what we're looking for, is things to be equal. So let's look at these examples of substitution. We're plugging it in to double check it. Well, we don't know what n is. Looking at this first one, n plus 8 equals 13. So I need to solve for n. That way I can see if the solution I come up with, does it work? So you see that I have addition here. And to undo the addition, the plus 8, what would I need to do to both sides? If I think of this as balancing it, using the equation as that middle marker, I would need to subtract 8. Remember, what I do to one side, I have to do to the other. So that plus 8 minus 8, they cancel each other out, and that leaves me with n. What is 13 minus 8? Well, that equals 5. Now remember, I want to double check things. I want to make sure, is that 5 really a solution to this? So I'm going to plug it in. 5 plus 8 is 13. 13 equals 13. Yes, that is the correct solution. I'm checking my work. Let's look at the second one. 20 equals y minus 3. So I want to get y by itself. I'm going to think of that equal sign as like the middle part and trying to balance both sides. So I have minus 3. What's the opposite of subtracting? The inverse operation would be to add. So what I do to one side, remember I have to do the other because I want to keep things balanced. So that minus 3 or negative 3 plus and plus 3, they cancel each other out. They make 0. So now I have the y by itself, and I want to know what it equals. So what is 20 plus 3? I'm going to do the math there on the left. That's 23. So I want to make sure it works. I plug it in. So 23 minus 3 is 20. Yes, it is a solution. 20 equals 20. Let's look at the third one. I want to get that x by itself. So if I have 9x, what operation is that when you have a coefficient and a variable next to each other like that? Well, that is multiplication. So again, balancing. I need to do the inverse operation, which would be division. So I would divide by 9 to both sides, keeping things balanced. So that 9 times and then divided by 9, they cancel each other out, and I get the variable x by itself. So what is 45 divided by 9? Well, that would be 5. Again, checking doesn't make sure. So if I plug it in, 9 times 5, is that 45? Yes, it is. Let's look at our last example, x divided by 3. So what is the inverse operation of division? Well, the opposite would be multiplication. So I need to multiply by 3 to both sides to get rid of the division of 3, or divided by 3. So that cancels each other out on the left, leaving the variable by itself. It's isolated, which is what I wanted. And 9 times 3 is 27. So checking my work, if I plug it in, 27 divided by 3, does that equal 9? Yes, it does. It is an appropriate solution. So here are really 4 good examples of using each type of inverse operation for you to have. At the end, you have some practice ones, and I would like you to do these on your own. And you can check your work when you're done.